Hello, and welcome back to another episode of Coven Season 3. This is a podcast where we commune with our dream coven, bringing to light the lost stories of enigmatic people throughout history whose fascinating lives echo the complex archetype of the witch. I'm Jenna.
I'm Coco.
And we're your hosts. Hello, welcome back.
Yeah, how are you doing today?
I'm good. Yeah, I don't know.
Any magic moments?
I was gonna ask you
if
you had any magic moments.
Yeah.
I always forget about this part until we're recording.
I know, right? Yeah, I have had a magic, well, I guess like several magic moments lately where I've been running into people in random places who go to CIIS. Yeah.
Cool.
Like online and in person and where I work and just kind of
that is cool.
Never heard about the school before, and now that I'm going there, I'm like, oh, you went there too? So.
Yeah. I mean, it makes sense the further we get into this work, the more we're just going to be like in the circles where other people, similar paths.
Yeah.
That is cool.
It is. I love it. It's like that we have this like knowing.
Like, oh, you see it too.
Right.
You get it. Sick. Well, should we jump right into it?
Yeah.
All right.
I'm excited.
So this is the part of the show where I will be telling a story of someone today. I've researched this person. Coco doesn't know who I've researched, and so I'm going to give Coco the birth chart of this person, and she's going to do a blind birth chart reading based on what she thinks this person might be like. So without further ado.
Whoa. Is this... Oh my gosh. See the shirt I'm wearing today?
Whoa. Whoa.
Yeah, weird.
Coco's shirt is,
My shirt, well, yeah, so this person was born in Tehran, Iran, and I'm wearing a shirt that's hashtag Iran. Okay. Grand Trine from... let's see here.
Oh, I should say I don't know the birth time.
Okay,
but so definitely the birthday. But I am very, very sure.
Pretty sure.
This, based on this person and events, I feel like this is with the help of Josh. Actually, shout out Josh. He's getting really into astrology, and he helped me figure out that she was probably a Gemini rising.
He is getting into astrology. I was really impressed the last time we all hung out. I was like, oh my gosh, you know a lot, Chris. You better catch up.
Gotta catch up.
Okay, so Grand Trine from both Mars and Venus conjunct pretty much, and Neptune and Saturn all in fire signs. And so, well, like someone... Does this person like, well, I'm just going to say, like, you know, again, we talked about this before, Venus and Mars, when they're conjunct, it reminds me of just like sex or passion. And then making a trine with Neptune, creative, like being creative about it. And then in group settings, and then also the emotions are involved. It's very like emotional. Probably also has to do with the physical body. And then Sun, Mercury, Chiron, and Taurus in the 12th house. And they are Gemini rising.
That's what I feel. Too? Yeah, okay. That's what I feel pretty strongly about. I was gonna maybe like give you a little hint of like focus on the houses.
Okay, cool, awesome. That's what I was wondering. And then Jupiter in the first house in Gemini with the ascendant. A lot of little tiny bits of communication. Jupiter is not really that happy in Gemini, and it's almost like it feels a little constricted. So I'm wondering if maybe that's a part of that this person's identity, feeling constricted in some way, wanting to communicate but not being able to for whatever reason, maybe socio-political reasons that have to do with the patriarchy once again, because Black Moon Lilith is there too. So there's something about this person embodying in their identity the characteristics of Black Moon Lilith, which I think I've told you this visual in my head of like what I think when I think
Mm-hmm.
of Black Moon Lilith. Should I say?
Yeah,
Or okay,
yeah.
just imagine a really beautiful woman, perfectly coiffed hair, makeup, smells good, wearing a long, beautiful, gorgeous dress, and then she pulls up her skirt or her dress to step up onto a step and you see her hairy legs. That's Black Moon Lilith. It's
Mm-hmm.
menstruation, it's breastfeeding, it's all the things that have been suppressed. And also a Mars, oh, opposition to Pluto too in the fifth house. Also, fifth house of pleasure, games, fun, sex and sexuality, children. And then, oh my gosh, Uranus also in the sixth house in Scorpio, opposing Chiron and Mercury in the 12th house. So there's something about the unseen, and digging things up and in something that has to do with like work or being in a place of being in service to um, awakening or chaos and disruption around digging things up and looking under the surface of things. And um and then the Pluto in the fifth house is throwing
Mm-hmm.
me off a little bit.
It's okay. Her chart is really accurate, but she is such a unique individual
Yeah,
that it's once we tell the story,
it'll
it'll
make
make so
sense.
much sense. And you are not far off at all. I
Okay,
like
okay,
there's
good.
certain things that like I just don't know about. So like the sexuality and those kinds of things, those are not central to her and her
Okay,
work. So I just have no way of knowing.
okay,
We
cool.
can infer maybe, I don't know.
Okay,
But that
okay.
was just not anything that was like
Um, there's also so her Saturn in the third house too. Something about structure and in Leo, structure, being seen, implementing structure, thinking about structure,
mhm,
maybe writing about structure,
mhm,
but also in a creative way, and that has to do with passion, and that has to do with relationships, and also again the group setting
mhm,
is like major because you got the south node, the lot of fortune, Venus, Mars, and their moon in Aries,
mhm,
initiatory energy too about it, like starting something.
mhm,
And her identity also having to do with death and dying or transcendence or depression or
mhm.
prison or
So many
hospitals.
things the 12th house could
Yeah,
represent.
yeah,
Yeah.
or hidden enemies. And but that grand trine too. I can't wait.
Mhm, mhm. Yeah.
Okay.
Yeah, this person is so interesting, and I am going to do my absolute best to do her justice. So the person that I am welcoming into our coven today is Maryam Mirzakhani. She is a renowned mathematician, a mystic of numbers. She is a
Oh,
bridge builder, and she's a revolutionary mathematician.
wow. Interesting. Okay. Okay.
Uh
Okay. The
huh.
Saturn in the third house in Leo.
Saturn in the third house. There's like so many ways the 12th house can be interpreted. And so it would have been insane if you made this connection. But the one of the main reasons why we ended up picking her as a Gemini rising is because her Gemini rising would make her chart ruler Mercury. And her Mercury is in Taurus. So to put Mercury in Taurus in the 12th house, her whole thing was on geometry and form and shape with like quantum subjects. So she was
Oh,
literally intellectualizing, theorizing form around impossible to conceptualize topics.
wow.
So that's why I think definitely like the
Like,
Taurus.
topics as in like infinity, topics like that,
We'll
like
get
trying
in.
to.
We'll get into
Okay,
it.
okay.
We'll get into it, and I will try my absolute hardest to explain. Um, but yeah, without further ado, okay. So Maryam Mirzakhani. She was born May 12th, 1977, in Tehran, Iran. She grew up in the aftermath of the Iran Revolution and during the Iran-Iraq War. So it was a really complicated time for women, kind of a dangerous time for women, but she was immediately recognized as a prodigy, just extremely brilliant. What she was originally passionate about and focused on was books and literature and reading and stories. She ended up attending a girls only school in Iran, and had aspirations of being a writer. But her junior and senior year of high school, she ended up competing in the Iranian National Olympiad, which is like this big math competition, and she won gold medal. Both her junior and senior year of high school. This.
Do you mind if I
Mhm,
ask you a quick question?
mhm.
Did you figure out like which house is math?
I this is what was this is tripping me up so much,
Okay.
um, because I think that like astrology is geometry. It is
Mm-hmm.
sacred geometry. So in
The
that
whole
way,
thing.
the whole thing is math. So I was trying to think about her specific type of math that she started focusing on and how where that would be. She ended up becoming a professor. So I think her 10th house or her ninth house midheaven
Oh
in
yeah.
Aquarius makes sense
Mm-hmm.
of like innovative thinking
I didn't even
of
look at that.
groups of people in the ninth house of like literally higher education.
Mm-hmm.
Um, when it comes to math, though, I don't know. I mean, I was thinking of like the air signs and like Mercury, like being able to like intellectualize, conceptualize these things. It's working with information, but like math is like everything, like it's in
Mm-hmm.
everything. There's so many different facets. But I picked the 12th house Taurus because the 12th house deals with the invisible and deals with what we don't understand.
Mm-hmm.
And Mercury in Taurus wants to create a really solid form of understanding.
Mm-hmm.
And she was
Mm-hmm.
working with shapes, she was working with geometry.
Okay. Okay.
So, in her specific case, I think the 12th house has to do with math. But I think you could argue that the third house could be
Mm-hmm.
related to math,
Mm-hmm.
like those immediate, like micro forms of information. You could make an argument for the ninth house, like the
Mm-hmm.
higher theoretical forms of information. Um, yeah,
Mm-hmm.
I
Mm-hmm.
feel like every house you could have an
Sh
argument.
yeah, she's got this kite um shape here too that I
Mm-hmm.
missed as well, which is like all pointing directly to, it's like between Neptune and Black Moon Lilith
Yeah, it's true.
and Jupiter, I guess, too.
Mm-hmm.
Interesting.
Yeah. So she's recognized as a prodigy. She is winning these awards. So winning the gold medal in the Iranian National Olympiad allowed her to bypass the National College entrance exam. Um, so she became the first Iranian to achieve. Um, okay, sorry, let me back up. So after competing in the Iranian National Olympiad, then she competed in the International Mathematical Olympiad the next year, and she became the first Iranian to achieve the full score and to win 2 gold medals in the International Mathematical Olympiad.
Wow.
On the 17th of March, 1998, there's a crazy traumatic experience where she's with a bunch of Olympiad competitors. She's with her friend Roya Bechetti Zavare, along with other attendees. They're on a bus en route to Tehran, and the bus fell off a cliff.
Oh my
Um,
God.
when this happened, 7 of the passengers died. Um, all students from the same university that they attended. And Mirzakhani and Zavare were two of the few survivors. So extremely traumatic event happening in her early years at university. Not much else in her story that I could find about that. Most of what I can find about her is her work. Even though she's like very, like, she's a modern person. She's somebody who unfortunately is not with us today.
Okay, I was like, is she still alive?
She's not still alive.
Okay.
But yeah, there's not a ton about her story beyond her work. But that did feel like something significant in her story. So at this university in Tehran, she earned a Bachelor of Science. And then she went to the States in 1999 to attend Harvard University to get her PhD. She got her PhD in 2004, and she was said to have been distinguished by determination and relentless questioning. She used to take her class notes in Persian, and she very soon after graduating became a professor at Princeton University, and then in 2009 became a professor at Stanford.
Wow.
So I think she was in her 20s or in her early 30s when she became a professor at Stanford. In 2014, she won the Fields Medal, which is the highest possible international honor for mathematics. It's the Nobel Prize of Math. But it's even harder to get than that. And she became the only woman to ever win the award, and still to this day is the only woman to win the award.
Wow.
The person who presented the award said, and this is where we're going to start to get into her work a little bit, but just bear with me.
Okay.
So I'm going to try to explain it more. But I just like this quote. Jordan Ellenberg presented the award saying, "Her work expertly blends dynamics with geometry. Among other things, she studies billiards. But now, in a move very characteristic of modern mathematics, it gets kind of meta. She considers not just one billiard table, but the universe of all possible billiard tables. And the kind of dynamics she studies doesn't directly concern the motion of the billiards on the table, but instead a transformation of the billiard table itself, which is changing its shape in a rule-governed way. If you like, the table itself moves like a strange planet around the universe of all possible tables. This isn't the kind of thing you do to win at pool, but it is the kind of thing you do to win Fields medals."
Wow. That is crazy. I think my brain just exploded a little bit.
That was confusing, but I'm going to try to explain it.
I think I understand it. Yeah, I mean, like you're looking at every single possibility of a thing, right? And then but she's also incorporating like movement of some kind, or
She's studying shapes.
okay.
She's studying surfaces. She's mapping surfaces.
Okay.
But yeah, that gave a little introduction of
That's
this.
the introduction. Wow.
So she would describe herself as a slow mathematician. She said that you have to spend energy and effort to see the beauty of math. So to solve her problems, what set her apart is instead of just using equations and numbers and theorizing, she would draw doodles and have giant pieces of paper on the floor and just be sketching these crazy shapes and these crazy images to help her understand what she was studying.
That's so cool.
So much so that she had a daughter who described her mom's work as, she thought her mom was a painter. She thought that she was an artist for work because she was just doodling all the time. And she said, "I don't have any particular recipe for developing new proofs. It's like being lost in a jungle and trying to use all the knowledge that you can gather to come up with new tricks. And with some luck, you might find your way out." Yeah, she was super excited about math when she learned. She originally didn't think that she was smart enough to pursue math, but she became really excited about it when she learned that she could view math and numbers and shapes like characters in a story that all interacted with one another. So she had a really creative way of thinking about math.
Love women.
Yeah, she when she could conceptualize it like a story, it became less about like finding the correct answer and more about discovering new territory. So when it came to the stuff that like we don't know, that's where she shined. That's where she like dove in. She didn't care about like
What we
winning.
already know.
Yeah, like solving equations to like
Be a better mathematician.
yeah,
She wanted to like learn things that we don't know about the universe
exactly. She
and
wanted to
geometry
make
and stuff.
discoveries through the language of math. One
Mm.
shape that she worked a lot with was the torus, which I think is funny because she was a Taurus.
Is that the shape of the Taurus glyph?
No, it's a donut shape.
Oh, okay.
But
Okay.
it's like, yeah, the torus is like what happens when you take a square on a flat plane. And if you take the square on the flat plane and you were to walk across the square and then end up on the same side of the square, and never mind, I'm not going to explain this very well. But a torus is a donut shape, essentially.
Okay. Okay.
So it's like what happens when you take a one-dimensional square, turn it into
A
a
donut.
two-dimensional square, and then a three-dimensional, or a two-dimensional object, and then a three-dimensional.
So a square on a flat sheet of paper, which would be two-dimensional, can be turned into a donut. Okay.
Yeah.
Okay.
Like if you get from this place to this place, but if you were to imagine that walking across the straight line would get you back at this place, what that essentially is going like this.
Okay.
And then the same thing happens when you want to go from this place to this
that
place.
place, then
it
that
goes
turns.
and it flips inward again, and you get a donut.
Okay. Yeah. Okay. Cool.
So she worked a lot with that to conceptualize her like theories and her formulas that she was developing.
Mm-hmm.
I just think that that is pretty neat that she was a Taurus and she worked a lot with Taurus shapes. Yeah. Unfortunately, she was diagnosed with breast cancer in 2013. And after a few years of tough battles, she passed away on July 14th, 2017, at just 40 years old.
Oh my gosh.
So very young and very tragic. She's buried not too far from here in San Jose. So probably will be worth a visit. She is extremely revolutionary in her contributions. I'm going to try to explain a little bit about what she was working on and what she just explained how revolutionary it was. So Maryam solved a problem that haunted mathematicians for decades, which was how to count certain types of geometric objects in impossible spaces. It's like being asked to count all the possible ways that a river can flow through a landscape that shifts and changes according to mystical laws. She was studying geodesics, and I'll explain what all of these are.
Okay.
She was studying geodesics in hyperbolic spaces. She was studying geodesics on Riemann surfaces in hyperbolic spaces.
Okay. Sounds cool.
And I just spent all morning doing a deep dive into what all of these words meant and what that means. So a geodesic is essentially the path that an object takes.
Okay.
So if you are thinking of a billiard table, the geodesic will be when you hit the ball, the billiard ball, where the geodesic goes, or where the ball goes is the geodesic. It's the path that it takes of least resistance. So when you hit the billiard ball, it goes from point A to point B. That path is the geodesic.
Okay.
But there are so many different geodesics depending on the direction that you hit the ball. So if you hit the ball in one direction, if you're setting it from point A to point B, there are so many different geodesics to get from point A to point B. It's just the path of least resistance that the ball is going to take.
Goes like this instead of going like this.
Exactly. You can like hit. You're also in a confined space where you can hit the side of the wall and it's going to bounce off and go. And you can study the probability of how many geodesics there are to get from point A to point B.
Okay.
So that is in a Euclidean model of science, which just means like a two-dimensional plane that we can observe. So when we're thinking about a geodesic, we can say in our plane of existence, what makes sense to us is we can form a square. We can walk, if we want to form a square, I can walk here, straight forward, turn 90 degrees, turn 90 degrees again, turn 90 degrees again, and I'll be back to my starting point.
Mm-hmm.
But if you're on a curved surface, it gets a little bit more complicated.
Okay.
It's not just a straight line to get from point A to point B. It becomes a curved line.
Okay.
Now, beyond that, if you're on a sphere, so one step above the flat plane, going from point A to point B, is a sphere, a curved plane. But on a perfect sphere, if you go from point A and keep walking, you're going to end up back where you started, and it's going to stay in that, like an equator. It's going to stay on that plane, on that geodesic forever. If you introduce dimension to this, now you're getting to the realm of hyperbolic spaces, where it's a curved space, a curved three-dimensional space that has more dimension. It's not a perfect sphere. So that's why you can think of like the torus, the shape of a donut, if like a three-dimensional donut. If you start a line on the torus and you just draw a path, you are not necessarily going to end up exactly where you started. But what she was trying to do was calculate how many times and in what directions you could end up at the exact same place on a
torus
complex shape.
Okay. I think I understand. So basically, she's trying to figure out what's it called? The
geodesic.
The geodesic, the path of least resistance from moving from point A and getting back to that same point.
Which is considered a closed geodesic, because you can go from point A to point B, and that's a geodesic. But then if you want to get from point A back to point A, that's a closed geodesic.
Okay.
So now we're going to take it a step further. So you can imagine that on
I'm horrible at math, Jenna. Why are you
You're
doing this to me?
You're doing a great job. You're doing a great job. So now you can imagine. Also, I am so novice when it comes to these things. This just comes from just a day's worth of research. So apologies to our listeners. Apologies to our listeners if I'm not making any sense. If you're a mathematician and you are like, this is, whatever, just give me some grace. Okay, so now I need to explain the concept of a Riemann surface.
Okay.
So a typical, I forget the terminology, but a one-dimensional Euclidean surface, or Euclidean surface, one-dimensional to two-dimensional surface, is just like, you can imagine like a flat plane. A Riemann surface would be a flat plane, but when you zoom in, it's comprised of like multiple layers.
Like texture?
Kind of, yeah.
Okay.
One way to conceptualize this is like in Euclidean mathematics, we can think of like there is like a solution, there's a problem, and there's one solution to it. There's an answer to every question. So 2 + 2 = 4. That is the answer to 2 + 2. There is no other answer. 2 + 2 = 4. However, you get into Riemann territory when you, Riemann, I'm not sure if I'm saying that correctly, but you get into Riemann territory when you look at like square roots of things, for example. So the square root of 4 is 2, but it's also -2. Okay. Because 2 times 2 is 4, but -2 times -2 is also 4.
Okay, yeah.
So now we have this complicated problem where there's two answers, there's two solutions to the one question.
One solution to two?
Well, there's just two correct answers to the square root of 4. There's not just one answer. And this doesn't...
I see. Okay.
That doesn't work in the Euclidean frame of mathematics, like the traditional, or not traditional, but the like one-dimensional or two-dimensional, I guess, perceptive field of mathematics. Like, it's complicated for us to hold two realities at once, to hold multiple realities at once. And this is where you get into the realm of quantum physics, because quantum physics is studying multiple realities at the same time. There isn't just a binary, one or the other. So Oh my God. Um, so, when you think of a Riemann surface, you're thinking of a quantum shape. A way that you can visualize this with the mathematical problem of the square root of 4, think of a parking garage.
Okay.
Think of a parking garage where the parking garage represents 4, the number 4.
Okay.
And there's 2 different levels inside the parking garage.
Mm-hmm.
A Riemann surface is something that connects 2 different realities into one shape smoothly.
Okay.
So the first level you can imagine is -2 times -2.
Can I ask you a question really fast?
Mm-hmm.
Okay, so you're basically trying to bring a mathematical concept into
Form.
Okay.
Exactly.
Okay, I get it.
Exactly.
I get it. Yeah.
So what I'm about to explain is not actually what a Riemann surface would look like, because this is something that exists in the 4th dimension, which is not something that we can actually conceptualize.
Right.
But it is what we are existing in.
Mm-hmm. Mm-hmm.
So that's why it's so hard to understand, because this is not something that we can actually visualize.
Because we are in it.
Mm-hmm. Yeah,
Mm-hmm.
it's not our perception. We can visualize 3D, but we can't visualize 4D.
Right.
But if you imagine the first level of this parking garage is -2 times -2, the second level of the parking garage is 2 times 2,
Mm-hmm.
and it's connected by, the spiral that is the path
Moving from the
up.
the first to the second.
Mm-hmm.
Uh-huh.
2 different floors,
Mm-hmm.
2 different realities, a part of the same structure, is kind of like a Riemann surface. Another way to think about this is John Steinbeck, or Anne Patchett, if you've ever read her.
Mm-hmm.
Authors who take very complex plot lines and like multi-generational stories and string them together into a way that makes sense, into a way that is like a fully formed story.
That connects them all
into one book, but you take them individually, separately, they're all individual stories.
Okay.
That's another way to conceptualize it. So now she's working with this idea in shapes.
Okay.
So there's not just it's like surfaces that we can't possibly measure because they're multidimensional.
Mm. Mm-hmm. Mm-hmm.
What she's studying is purely theoretical, how to find the geodesics of Riemann surfaces.
Okay. Okay. So she's trying to find the path of least resistance between these these different points in mathematics, but in form.
Yeah, in form of a multidimensional shape.
Okay. Yeah.
Yeah.
I the only reason I think I get it is because like on TikTok there's this guy that like has this thing, and he's like, this is what the 4th dimension would look like, and it's like all these different shapes, and it's like mirrors everywhere, and it's like
exactly. So she developed formulas to measure the geodesics of these theoretical shapes.
So she's like basically expanding people's minds to try to understand something that we can't possibly perceive. Wow.
Yeah. So she was able to, by studying, by learning these geodesics, she's able to effectively map quantum spaces.
Wow.
Because when you're studying like the path of least resistance from one point to another point, you're able to visualize what the might look like. Right?
Interesting. So, you're doing great, Jenna.
Thank you.
I don't know how you remember all this shit.
I mean, I did write it. It's also fresh on my mind. So this is really powerful for so many reasons. But one of the things that this really applies to that's really exciting is the concept of string theory. Mm-hmm. So string theory, the way that it makes the most sense to me is thinking of it like an instrument. If you think of a guitar has strings attached to it. And when you play a string, it vibrates at a specific frequency, depending on what it's tuned to, depending on the strings around it, it's going to sound like something different. There's the concept of harmonics, and depending on the shape of the guitar, the size of the guitar, the kind of wood that the guitar is, all of these things affect the quality of the sound when you pluck the string.
Right.
String theory is the idea that particles in our universe, everything that this is made up of, is just these like microscopic strings, and every time one is affected, it's affected by everything else.
Yeah.
And right,
Yeah.
this is like this is like Interstellar, all of these movies, and Stephen Hawking. This is string theory.
Like if I like do this to this couch, something way on the other side of the universe is like affected or feels it, or
yeah, just that everything is like intrinsically connected with
Yeah.
harmonics. But this is like a really hard thing to actually measure and to actually study, because unlike a guitar, like on a guitar, you can, with acoustical physics, you can predict the exact amount that, like, the type of frequency. You can use a formula based on the size of the guitar, based on where the string is, how the string is tuned, the kinds of everything that's a factor in this guitar. You can predict the frequency that a string is going to vibrate at.
Right.
Using a formula, because you have the shape of the guitar, because you know
all
everything
the
about it.
Yeah.
Exactly. What her theory helps with is she was essentially using these geodesics. She was able to calculate the geodesics, which helped her map the surface area of these complex shapes called Riemann surfaces. So we can't study the vibrational frequency of these strings that comprise of all of our experience, because we have no way of measuring the surface, because it's a complex shape. It's a Riemann surface. It's a Riemann surface.
And from the perspective that we're coming from.
Exactly.
Like, yeah.
It's impossible to measure.
Yeah. We'd have to be like a bigger giant than the universe to be able to like look at it and be like, okay, here's what's going on. But from our perspective, we can't see it. So you have to use math to try to figure it out.
And she created a formula that could measure all possible geodesics in these hyperbolic spaces, in these Riemann surfaces, so that you can actually sort of map out the shape, like topography, of these complex spaces that we are actually existing in. Like, this reality is a Riemann surface. It's like one of those layered, complex quantum fields.
Yeah.
So she's able to conceptualize the topography of like the shape of the universe, which helps to understand string theory and quantum possibilities.
Wow. That is so cool. That is so cool.
Yeah. And there's so much more that goes into it, but I feel like I'm just getting so ahead of myself and out of time. But
well, I had brought up infinity earlier. Like, I don't know if this has anything to do with it, but infinity confuses me. I saw this documentary on Netflix, and it's like infinity is confusing to mathematicians because it right when you think it makes sense, then it doesn't make sense anymore.
Yeah, and I think that's really similar with the fourth dimension. It's something that has to entirely live in your it's only theoretical. You can't, there's nothing you can draw to actually visualize it. I think what helped me understand it the best was in conceptualizing all of our reality as a shape. If we were to create everything that we know, everything that we're witnessing, everything that we're a part of, if there was a shape to it that you could measure, that's what she was figuring out. And it helped me understand too with the string theory, thinking of if it was a shape that you could measure and there were strings attached to it, it's like essentially you can understand the harmonics of the universe.
Wow.
So her work, she was essentially studying geometry that would determine which quantum realities are more or less likely to exist.
Whoa.
So she was mapping the shape of possibility itself. And I said, like building stairs to get from one space to another. The space was there. The stairs represent new ways to observe and interact with the space. So she was essentially building architecture, building structure around what's already there, but what we can't conceptualize. And when she builds something, it helps us to conceptualize that space.
So when you say she's building something, so she's not like okay, let me just see if I got this right. Okay. So she's figuring out basically like the structure of the universe, and she's building something through conceptualizing shapes in order for us to better understand it.
Yes. Yeah.
So
for
it's not
us
like
to be able to like observe it. She created a formula. She created formulas
okay.
for us to be able to begin conceptualizing
Is it
these
like
shapes.
it's like she's building a scaffolding
Yeah.
in the universe.
Exactly.
Okay.
That's how
Okay.
Josh put it too.
Oh,
Kind of the
all right,
scaffolding.
Josh. Great minds.
Yeah, just really crazy, really wild shit. And I watched a video of her giving a lecture on all of this, and I just could not. I could not keep up in any way. She's one of those people that is so, first of all, she was known as being just really humble, really grounded, really down to earth.
Taurus.
Yeah, the Taurus. She's one of those people who just is so clearly brilliant beyond a body that like for her to give a lecture and to have to explain everything that she's processing was so difficult. She was like going all over the place. She would like start on one thing and then she would be like, but actually I have to explain this, and she'd be like half erasing the chalkboard and then drawing something else. And I was like, I cannot.
I saw someone on TikTok basically say something along the lines of like the more intelligent you get, the lonelier it gets because
you can't translate. Yeah.
Right. And you're having to like explain concepts that are difficult for
Right.
people to understand unless they have the foundation,
the language already.
Yeah.
And for her,
you did a really good job though.
Thank you. For her, the language was numbers, was math. She was able to translate these complex ideas and help people, give people these visuals that she was having through the language of numbers.
Wow.
Pretty powerful stuff.
That's really cool.
Yeah. This is a chart. We don't need to get into this, but when she won the Fields Award, this was the chart, the transit chart for that.
Oh, wow. Well, Uranus conjunct her Venus Mars right there. And oh my goodness. Yeah. See, I knew that Saturn by itself in the third house in Leo had something to do with it, especially because of that grand trine. It's almost pointing directly at it. It's like all of this creativity between these two is pointing directly right here at structure in our local environment.
Yes. Yes.
And it's also about learning. And then you have Venus, Jupiter, Black Moon, Lilith, the Sun, and Mercury all like in the third house while this award is happening. It's almost like look at the beauty in it, here's and shining a light on it. And yeah, that's really cool.
Yeah, and I think the third house as opposed to the ninth house, because it wasn't like her work was being published. She was just getting recognized for the work that she was doing like on her own, like in her own spaces. I feel like third house versus ninth house is like doing the work and studying and researching versus sharing the work and publishing, It was like...
Well, and I also feel like ninth house is research and writing and publishing about things that already exist. This is what we learn. This is something that's like new conceptually, that we've never known before, because like, when we were talking about in our natal chart, it's, we were born, our identity, we realize, there are things outside of us. And then it's like, wait, we have the ability to conceptualize lots of things.
And then she does have a lot in the 10th house happening. I guess Neptune and the moon, Uranus in the 11th house over all of her Aries placements.
Wow.
Yeah. So
very cool.
Yeah, she was a theoretical architect of spaces beyond our perceptible dimensions. By developing formulas that could measure these spaces, she helped to create form around them, allowing us to visualize new dimensions through the theoretical scaffolding she set up around it. I think she is an absolute magician and mystic of numbers, and she's completely revolutionary in the way that she saw the world, the way she was able to translate these ideas. And I think we are just beginning to understand the implications of her work. I think.
Sorry, when you just said magician, that also just makes me think of the third house, because it makes me think of Mercury, and it makes me think of like the trickster and Hermes, and so that tracks too.
Yeah.
Yeah.
Yeah, she was just able to like understand these topics that nobody could understand. I mean, these were topics that people were struggling with for decades. Like, as long as people could conceptualize a fourth dimension, it's been impossible to understand how to observe it, how to measure it.
Yeah.
And she created these formulas that provided a bridge to get there. And unfortunately, she passed away so young, so tragically. And I'm sure that so many people will build on the foundation of her work to do incredible things and to make massive discoveries about quantum realities and different dimensions.
That's really cool. I've always been really interested in string theory and quantum physics and all of that, and infinity. Infinity in particular is something that I always think about, and how interesting it is, and just how you observe it in everything around us. And it's like a concept that you understand, but yeah, you can't really, like, how do you explain something that is but also is not?
Exactly. You have to go beyond what we have capacity for with language.
Yeah. Wow.
So that's why I'm welcoming Maryam Mirzakhani into our coven today.
Welcome, Maryam. Who's she hanging out with?
Oh my goodness. Who is she hanging out with? She is so different from everybody that we have invited into our coven so far. I mean, Hypatia of Alexandria was also a mathematician and astronomer and philosopher, so definitely Hypatia.
Yeah, maybe Sor Juana.
Yeah, true. She was also a mathematician, wasn't she?
Just scholar.
Oh, scholar, philosopher.
Yeah. And yeah. Cool. Amazing.
Just definitely be with the academia nerds in the group.
Yeah, that's what I was trying to think of. Who are the academics?
Yeah.
All right. Well, that's wonderful. Thank you. And I guess we'll see y'all next time.
Wait, do you have a hint about your next person?
Oh, yeah. I'll say imagining other realities.
Ooh, okay. Same vibe.
Yeah.
Hell yeah. All right.
As always.
We'll see y'all next time. This has been another episode of Coven. Thank you.
Bye.